So today's lecture, we're going to be talking about multithreading. So multithreading is kind of an interesting concept, and it can be a little bit of a learning curve. So we'll take it one step at a time. So first, let's think about the human body and how it can do things concurrently. Like we can breathe, our heart can pump, we can have digestion going on, thinking. So we're doing all of these things all at the exact same time. Well, computers can also do multiple things at the exact same time, and it does that via multi-threading. So if you have more than one processor or core, then you can create a separate thread in order to execute on multiple cores so that you can do the same, or you can have multiple things at once. So we call this threads of execution. And a thread is just a method that you call that you start on this different thread. So for instance, there's a UI thread. So the UI thread handles everything going on with the UI. You can then spawn a thread that happens behind the scenes so that your UI doesn't get locked up, but you can do some other work while you're still responsive to the user on the UI. So in order for us to be able to do threading, we need to include the namespace System.Threading in our application. An example of something that uses threading is the garbage collector. So as we instantiate memory, the garbage collector is constantly waking up on a separate thread, figuring out which memory can be reclaimed, and then it can reclaim it. Now, in order to start up a thread, the method that we call that's going to be starting in this new thread has to return a void and take no arguments. And we'll see why that is in just a second. A thread can be stopped at any time by calling the abort method. So right during the middle of it, you can go ahead and stop it. So we can also call thread.sleep, which will pause that thread at a particular moment. Maybe we need to wait a certain amount of time for something else to take place. With our thread, we can also set its priority of lowest, below normal, normal, above normal, and highest based on what sort of application you're creating or what you're trying to handle behind the scenes. Most of the time, I just leave it as normal. If you really want to have a great reason why you don't do it on normal, because you can just kind of hurt yourself if you get kind of too deep into it. Another thing is Windows uses a concept called time slicing, which back in the day, when there was just single processors, you could see the processor would be given to one thread and the processor would be given to another thread. So it really was only doing one thing at a time, but it was able to create these time slices and go back and forth fast enough that it looked like things were happening at the same time. Where in today's environment, we actually can do things at the same time. So now let's go into some code from the book here, and we're going to create this thread tester application. And so as we go through here, let's first look at this message printer class that they created. So they just created this down below here. You can see it has an integer for sleep time, so how long this thread will sleep. And then they just have this random variable here to create so random intervals in sleep time. So you can see here in our constructor, it's just a random between 0 and 5. So it could be 1 second or 3 seconds, but it's random every single time you create a new message printer class. There's just one method in here that's we're going to call on a separate thread. So this will be the first time we have something that executes behind the scenes and not actually on the UI thread, which is what we've all done to this point. So we can use the thread class, and so here is a static get where we can just get a reference to the current thread that we're executing on. So that's what this does right here. It just gives us a handle to the current thread that's executing. From there, you can see that we can print out the name for what a thread is executing, and we can also make it go to sleep for the given amount of time that was done up here. And then down here, we say it's done sleeping. So it's just showing you that it goes to sleep and then it wakes back up at these random times. So up here, we instantiate that object. Now we can use the thread class in order to instantiate a new thread. And you notice at the top here we've got using System.Threading. So we say thread equals a new thread. So again, this is that background thread of execution we're creating. The constructor, you'll see that it takes a thread start So if I highlight this, you can see that's a delegate. Well, we've learned about delegates. Let's go take a look at what this delegate does. And this delegate just defines that whatever method you're passing in has to return a void and take no parameters. That's what our thread start has to have. Well, if you'll notice, here's our printer object. Which method does that? Print. You can see that it returns void and takes no arguments. So what we're saying is hey, we're instantiating this new thread here, and when we start this thread, we're going to call this method. Here we're just going to name the thread itself. Do the same thing for thread 2, do the same thing for thread 3. Now remember the constructor here, when we called it, it created a random sleep time between 0 and 5. And that way each object is going to have its own unique sleep time. Now what we can do is we can say thread.start. So when we say thread.start, it doesn't come down here and start just executing this method. What it does is it calls this, which instantiates a whole separate thread, which starts executing at the exact same time as this next line of code and then this next line of code. So as soon as this executes, it actually goes right on to the next line and then right on to the next line. And then behind the scenes, these threads all start this print method at the exact same time. And they'll print out different values based on that random sleep time. So that's how this method or this application works. So if we say console.read, just to make sure it stops, we'll go ahead and run it. And you can see now, 1's going to sleep for this amount of time, 2's going to sleep, and then they're done sleeping, and then they wake back up. But again, they're random based on the amount of work that each one took. So the concept is that if you can think about pieces of work like this that you can do that's completely independent. Now let's imagine this was sorting some massive amount of data. And so maybe there's 3 large sets of data we want to try to sort or search all at the exact same time. Well, that's kind of what we're doing here. So we're saying, hey, start up this big chunk of work. And let's pretend this takes a minute, each one of these. So we're starting up, this one takes a minute, this one takes a minute and a half, this one takes 45 seconds. But because we can run them in parallel, we're creating these new threads in order to do that work. So this next application, this 15.8, is about unsynchronized buffer. And so what we mean by that is if we're doing multiple threads but we're accessing the same piece of information, we have to synchronize as we get or set that data if multiple threads are accessing the shared data. So let's take a look at this one where we're going to have this interface called buffer. Very simple. It just says, hey, if you implement this interface, you have to have an int buffer property. Our unsynchronized buffer class, you'll notice, implements our buffer interface. So there you'll notice that there will be a buffer property, and sure enough, within our unsynchronized buffer. Now it's unsynchronized because what that means is we're going to instantiate an object over here of unsynchronized buffer. So this right here. So see how we create this object here? We're calling it shared because if we instantiate the object and then we only use one object, we're going to share this integer amongst several classes. So two other objects are actually going to share this piece of information, that integer value. And that's what this producer and consumer class do. You can see how they're passing in the same object, which means they're both going to reference this same buffer ID. And so the problem is that you can get and set the data at the same time. And so that's going to create some issues. So let's take a look at the producer class. So here's where we're going to have that buffer passed into us. So that's this line of code right here, where we instantiate the shared data, and then we're going to pass in that shared variable. So in the constructor, we pass that in, and then we also have a random sleep time. Now the produce method comes in here, puts the current thread to sleep some random amount of time, and then you'll notice that it just keeps updating the count of the buffer. So it just puts 1, then 2, then 3, then 4, all the way, and in between that it has amount of time it sleeps. And so this is where we're saying that we're having a random amount of time where this sets it, and now our consumer over here at a random amount of time is going to consume that same buffer value. So you can see here that this buffer is shared, that's getting passed into our consumer class. So the producer produces value and the consumer consumes the value of that same memory location. So we come over here, we instantiate that shared unsynchronized buffer. we create our producer and consumer classes, we create a thread, and we say we want to call producer.produce on this thread and consumer.consume on this thread, and then we start both of our threads. And so let's watch what actually happens now. When we run this application, what we would normally want is the producer to write, consumer to read, producer to write, consumer to read. But you can see in this case right here, the producer actually wrote 2 and then wrote 3. And then the consumer read 3 and then read 3 again, so it never read the value 2. So this is where that synchronization would come in. So let's take a look at how you'd actually do that. So this next example from our book talks about synchronization. So when we're sharing data and we only want to give exclusive access to one thread at a time. So we've got the same interface buffer, but now this is the only thing that changed in our code is this synchronized buffer class. One, we've got the same integer shared buffer, and we have another variable that's going to tell us whether or not a value has actually been put into buffer. So you notice that it's 0 right now. So here, we're just going to have the public get of our buffer property. Now here's a new concept. This is called the monitor class. And the monitor class is used to lock objects down so we can implement synchronization. So locking an object means that only one thread can have access to that object at a time. So when we say monitor.enter this, we're saying this object that we're currently working in, this synchronized buffer object, lock it down so that no other thread can access this code or any other locked down code during this. And so it'll make sense as we walk through it. So let's pretend we're getting a value. The first thing we say is, hey, this object, I'm locking it down. I don't want anyone to produce a value while I'm getting a value. So first I looked at this buffer and I say, is the buffer 0, which means it's empty. So it just writes out a method that says the buffer was empty. And you can see we say monitor.wait this. What this means is that, hey, I know that we have this idea of a producer and consumer, and so this releases that lock on the object, and it just waits until someone else tells us, the other thread tells us, hey, I've produced it, you can consume it again. So this thread will pause right here and just wait until the other thread tells it it can start consuming again. Now let's pretend that that buffer was 1. So we would skip over this. We would decrement the buffer because we want to then read it out. Now this is kind of interesting where we have to say monitor.pulse. So we're basically telling the other threads, hey, we're just about to release our lock, so get ready. Here what we're doing is we're actually making a copy of this buffer value. Then we release the lock, then we return the buffer copy. Now why did we have to do this? Well, what would happen if we didn't just delete this line of code? Now watch what happens. If you do monitor.exit and then you just returned the buffer on this next line of code, in between this line and this line, it's possible that the other thread would actually write a value to the buffer and overwrite the current value in there. So that's why we make a copy, release the lock, and then return this copy here. Now if we're setting it, we do something very similar. We say monitor.enter, and so we lock down the object. And so if this thread is now executing this, and then we're on this line of code, and now this thread starts executing, when it gets to right here, because that other thread has the lock, it will just sit here and wait for that other thread to pulse it. So if we notice that the buffer is already full, then we just wait right here until this one up here would pulse us to wake up and then release the lock. Now if we're trying to set the value, here we set the buffer, increment the buffer count, release, or we tell the other threads to, hey, wake up, we're going to start doing this, pulse them, and then release the lock so that the other thread can start. Another thing that we could do is you could actually use what's called the lock keyword, and so you say lock this, and this is exactly the same as having this monitor.enter here and then the lock this. I prefer using the lock keyword. It's just a little bit more straightforward and user-friendly, and it releases the lock if an exception gets thrown in between it. Now over here on our producer class, it's exactly the same. So it just produces, and you'll notice that this calls this buffer, which takes care of all the synchronization that we need, the gets and sets here from our buffer class. Same thing with the consumer over here, it stays exactly the same. So now we do synchronize buffer, we create both, we set up our threads, and we start both our threads. But now watch what happens when we run these. So you can see that the producer writes 1, and then the consumer reads 1. And then everything is going here. Oh, the consumer tried to read again, but now we're told that it has to wait until we consume 3. And so by synchronizing this, we're guaranteed never to miss a value, and we're going to stay synced up. Next concept I want to talk about is user interface threading. So how we're actually going to use this multiple threading on the UI. So it's a little bit tricky because the UI executes on a thread, and any of these threads that we start up execute on a separate thread. These separate threads, you would not want to update the UI. As a matter of fact, you can't up the UI because it doesn't know anything about the UI because it's on a separate thread. So how do we interact with the UI on a separate thread? Well, I'm going to show you a couple different ways. So first, on this method here, we're going to click our button, and this is just going to instantiate the separate thread in the way that we've learned so far. So you'll notice I'm just setting this begin message. So you start it, I begin the message, I instantiate a new thread, and I call my thread method. Now normally my thread method, you'd want to put this in a separate class so that that class is creating that business logic where we're going to separate our other thread. But we're just doing it here for simplicity's sake. So when this thread starts, you can see I'm putting my thread to sleep. This is a background thread. If I were to say thread.sleep up here, that would put my UI to sleep and it would lock it down. That's not what we want. We always want to make sure we keep our UI responsive. So you always want as little code execute here as possible because all of this code has to finish executing before the UI responsiveness is going to come back. So down here on my thread method, this is going to pause the thread. This simulates just doing a bunch of work. This is showing you that this line of code would actually throw an exception. So even though this method is behind the UI in this class here, because this is getting called on a separate thread, we can't update the UI via a separate thread. In order to do that, you have to do what's called invoking or passing this work to the UI. In order to do that, you can access any of the controls on the UI, and we have to use this invoke method. And what this says is, this says, hey UI, I've got some work that you need to complete. For instance, maybe displaying that, hey, we're finished processing to the user. So what we can do is we can say invoke, and you can see invoke takes a delegate. And so our delegate here, new display message delegate, so it's up here. You can see that our delegate is void and takes no parameters. And so I instantiate that and I say, hey, call the display message. So what this is saying is, it says, hey UI, I've got some work I need you to do, and this is the method work that I need. So this actually does get executed on the UI thread. So all of this would be all the complicated work in the business logic class behind the scenes, and then this is sending that work to the UI that says, hey, we're done, essentially. The next concept is something called a background worker. I like the background worker because it's an object that .NET was created for us to kind of abstract this threading logic, so it's a little bit easier to use. Now, I actually dragged and dropped this onto the UI because Windows Forms you can do that. You can drag and drop it here. Then you'll notice I've handled, so here's the properties, here's the events, and so I'm handling the do work event, the progress changed event, and run worker completed event. And so I just double clicked over here and that created the methods for me. So let's show you how you can use this background worker now. So it instantiated the background worker for me automatically when I dragged it over to here, and it put it down here. And so all you do is say run worker async. So we're saying run this work and do it asynchronously. When you say run worker async, it continues executing on. So it executes this and then just moves right on. But then it also continues executing this in parallel. And so you can see this just pretends it's doing some work behind the scenes. What's nice about the background worker is it has this report progress mechanism built into it. And so on this background changed event, you see how I say report progress and it passes in a number? Well, I can say e.progress percentage and I can report that value that I sent out of my method here. So you can see that I'm doing a lot of work, but then I'm reporting to the UI, hey, I'm 25%, 50%, so I'm keeping my user engaged and they know what's going on. The next thing was this background worker is after it's completed executing all of this, it automatically calls this run worker completed method. and then you can update the UI. So this one actually does run on the UI. This one runs in the background thread, and this one runs also on the UI. So that's what's kind of nice about this background worker. But again, all of this code you'd want to put in a business logic class. So the next one, I want to talk about threading for a Wpf application because it's slightly different. So first, let's come down to this command start click. So you notice I instantiate a thread. I want it to call my thread method. So you notice it does exactly the same thing here for this invoke. Here I'm calling begin invoke versus invoke like I called over here. So invoke, what it does is it says, hey, call this method, but wait here until this work is done, then continue executing on. Begin invoke says, hey, just continue executing right on and also start doing this work. But you'll notice it's exactly the same between the Windows Forms and the WPF. So we can use this LBL invoke, or in WPF you have to use what's called the dispatcher. This.dispatcher.begin invoke. So those are kind of the differences between Windows Forms and WPF. So the next thing is I want to create another background worker. So now I'm going to actually code it, which is the way I would recommend doing it. So here's my background worker. I'm going to instantiate the background worker. I'm going to say reports progress true so that we can do this progress changed event. And then for do work, progress changed, run worker completed, I'm going to instantiate these delegates and then tell it which method to handle these different events. So then when we come down here, I'm going to say we've started, and then I'm going to say my background worker, run worker async. In do work, I'm going to do the exact same thing. And then my progress changed event gets ran whenever I do this. And then at the end of this method, my run worker completed would run. Now a new concept here, and you'll see right here I don't have any try-catch blocks. And the reason for that is if there's ever an exception that's thrown within this do work method, it automatically gets raised up to this run worker completed. And all you have to do is say e.error and see if that is null. So if any exception was thrown up here, then it automatically gets caught and raised up to this run worker completed. So that's kind of a basic introduction to threading. And if you have any questions, let me know.